If you're watching this video, that probably means you're holding a paper that looks like mine, where it says Unit 2, Module 4, Session 1, and the title of this assignment is Multiplying and Dividing. Little house there because this is a home connection. It is homework. This first part is going to be really hard for me to help you with, but I can just give you just a couple clues. Your top row is basic math facts, single-digit multiplying. Hopefully you have a bunch of these memorized, or you can skip count pretty quickly. In the bottom row, it might be helpful just to know that you might want to word it 8 times what is 56, 9 times what is 63, what times 5 is 25, okay? Just by phrasing it that way, you might get your brain ready for it, okay? Pause this video if you need to work on those and do those real quick, and then you can just hit play when you're ready for number 2. But I'm going to hop into number 2 just to save time on this video. We have multiplication tables, but they have jumbled them up. So we have 2 times 5, 2 times 2, 2 times 9, 2 times 3, so on and so forth, and they wrote the answer down below. This is an example, by the way. They did this one for you. Isn't that nice? Then you get to take 10 times all of these numbers. Hopefully you remember that when you take any number times 10, the answer is that number with a 0 placed on the end, right? When you go into the next row, taking 5 times all of these numbers, which should be half of what this is, right? Because 5 is half of 10, so whatever this answer is, it must be half of this. So 5 times 5 is 25, which is half of 50, okay? Then you're going to be taking these times 9, just as a quick reminder. Maybe I'll zoom in so you can see this pretty well. If I take any number times 9, or if I just count by 9s, if I think of 9 as this, that would be 9 times 1. Well, if I do 9 times 2, I'm going to add 1 here and subtract 1 here. 0 becomes 1, 9 becomes 8. 9 times 3 would be add 1 here, subtract 1 here. And then this continues. The 2 becomes a 3, the 7 becomes a 6, the 3 becomes a 4, the 6 becomes a 5, the 4 becomes a 5, the 5 becomes a 4. So all of these numbers on the right side are getting smaller, while all of the ones on the left are getting larger. So this would be like 9 times 1, right? If I took 9 times 2, I'd get 18. Times 3 is 27. Times 4 is 45. Times, 1, 2, 3, 4, 5. Times 6. Okay? So that's just a little FYI for you. So that's a little trick. Some people know it really well. Some people, this might be brand new to you, but it is pretty cool that you just count up on the left and down on the right. Okay? So make sure you work on those tables. Now on number 3, use what you know about multiplying by 10 to help solve these problems. So they're giving you a hint that you don't necessarily have to do the algorithm to figure these out, which we could, but we know that any number times 10 is that number with a 0 placed on the end. Okay? 12 times 10 is 120. 12 times 5 should be what? Compare 10 to 5. If 12 times 10 is 120, 12 times 5 should be half of whatever this is. A couple ways you could do that. I kind of like to do this. Cover up the 0. What's half of 12? 6. Put the 0 back on the end. That's your answer. Now, you could do it another way. You could think to yourself, well, I could say, well, half of 100, so if I do half of 100, that's 50. Half of 20 is 10. Combine those two and you get 60 again. Another way, I feel like my camera's just a little unfocused. Give me a second here. Let me see if I can trick it into being nicer. That seems a little better. And one other way that you could do this is you could say 5 times 10 is 50. 5 times 2 is 10. Combine them. Do you notice how those ended up being the same? Still get the same answer, 60. Okay? Now you're still working with 12s. Couldn't we just make this 10? 12 times 10 is 120. But that's one too many, right? So we'll just subtract 12 from it and get an answer. I'm going to let you do that on your own. Okay? And then if you look at these last ones, I'm not sure what's going on here, but we have an 18 times 10. Over here we have another 18 times 10. So I'm thinking that was a mistake on their part, but maybe you're just really lucky. Maybe, I'm guessing they probably wanted to say 18 times 9. But use what we did in these 3 problems to solve these last 3. Pause this video if you need to, and then flip the page over when you're ready. And hit play, of course. Let's see, you gotta zoom out so we can see all of this question. Okay, is that all of it? There we go. Mrs. Larson was making gift bags for the 6 students in her reading group. Making gift bags for the 6 students. She was putting little erasers in the bags. She had a bag of 20 erasers. How many erasers did each student get? Show your work. Now, you could draw this out, and that's what we're going to start with. Okay? I'm just going to draw these little, we'll say that these are little paper bags. Maybe I could do a little frilly at the top to make sure they look like bags. And there's 6 students, so they each get a bag. Okay? That's 4. There's 5. There's 6. Okay? She has 20 erasers that she's going to give. She's going to give some to each bag until she basically can't give any equally anymore. Okay? Well, if I counted on a number, well, now let's draw it out. Let's do this. So I've got 1 in each bag, so that's 6. Let's do another mark. So now we're going to put a second eraser in each bag. Now there's a total of 12. I'm going to put another one in each bag. So now I've got 3 erasers in each bag. Now I'm up to 18. That's pretty close to 20. But I don't have enough to give everybody another one because I only have 2 more. And we want to be fair, right? I can't give these 2 people 2 and then not give them, right? So we can't do that, right? We have given everybody 3. We're up to 18. I don't have enough to give anybody else. So how many erasers do I have left? Well, this bag has 2 left, right? So what would be the answer to this problem? Is that how many erasers did each student get? They would get 3 erasers. And if you wanted to, you could be fancy and say that there were 2 left. Oops. 2 erasers left. Now, over here I was going to think about doing a number line, right? Because some people really love to do some skip counting. And if we do that, we start at 0. Everybody gets 1, 6. Everybody gets 1, 12. Everybody gets 1, 18. Everybody gets 1, 24. Uh-oh, I don't have 24 erasers. So that's how I know that this is where I stop. And everybody gets 1, 2, 3 erasers. So that's a number line way of thinking it. You could do a ratio table. You could do an open array. Lots of ways you could do it. So you have some choices. Now that one I guided you quite a bit on. This one I'm going to set you up, but I'm going to let you solve this. The teacher wanted his class to work in groups of 4. After he divided them into groups, there were 6 groups of 4 and 1 group of 3. How many students were in the class? 6 groups of 4. So I had 6 groups that each had 4 in them. Okay? And then I had 1 group that has 3 in it. So you're going to total all of those problems, and then you are going to know how many students are in the whole class. Okay? On the last question, you have, if the teacher wanted all the groups to be exactly the same size, how many students should be in each group? Okay? So you're going to have to know the answer from this problem in order to know how to divide the students equally. Okay? Now, I feel like I have to at least come up with some number. I have 24. I have 3. I have a total of 27. Oh gosh, I hate giving answers. So on this one though, and we're going to have to do some division, okay? So I have 27 students, and I need to divide them equally to get a certain number in each group, okay? So let's find this out. We could do maybe a factor rainbow, right? What do we know about the number 27? Well, 27 can be split into singles. Like if you didn't want to do groups, you could have 27 groups of 1, You could also do 3 groups of 9. 9 times 3 is 27. Or you could even say that you could do 3 groups of 9. So that could be interesting. Now, the teacher wanted them to work in groups of 4, right? That's what he wanted. So this is probably close enough. So I'm going to let you figure out how you're going to divide 27 by how many groups to know how many are going to be in each group. But I think these are 2 numbers that you're going to want to work with. And make sure you answer the question, how many students should be in each group? So you're going to write blank students in each group. How many small groups will there be? Right? Then there will be blank groups. Okay? And I'm going to let you decide using maybe our factor rainbow. I guess I could rainbow it out so it actually makes sense. Okay? To figure out how you want to split those groups. Okay? Talk to your teacher if you need help, or talk to someone who you feel comfortable bothering about math. Have a good one.